Today's topic is self-organizing map. It's an unsupervised learning neural network. It maps multidimensional data into a two-dimensional grid. So the neurons are arranged in two-dimensional grid. Each neuron contains a weight vector like RGB values. So the algorithm states initialize the weights. It may be random numbers iterated through the inputs given. For each input, find the winning neuron using the Euclidean distance between the points. Adjust the winning neurons and its neighbor by Gaussian or Mexican hat. And then use optimization algorithms to streamline the output, reducing the input and output neuron dimensionality by random projection method, pre-generating the neuron weights, initialize the maps, and recreating the winning neuron search. So the advantages is data mapping is usually interpreted for organizing complex data sets. Disadvantages: difficult to determine what input weights to use, and since our input weights are random, mapping can result in divided clusters. It's used in phonetic typewriters, classifying word poverty, etc. So we have the neighbor topologies in KSOM, Cohen SOM. There are two topologies, rectangular topology and hexagonal grid topology. This is the structure of the rectangular topology. This hash sign indicates the winning neuron. Surrounding it in the initial first grid, we have 8 nodes in a distance 0. And in the second grid, we have 16 nodes. And in the third grid, 24 nodes are there in rectangular topology. In hexagonal grid topology, same way this hash is the winning node. Surrounding it in 0 distance, we have 6 nodes. In 12 distance, we have 12. In second 1 distance, we have 12 nodes, and third we have 18 nodes surrounding the winning neuron. So the difference between each hexagonal grid is 6 nodes. The architecture of SOM, KSOM, Cohen self-organizing map. So we have the input features given to the input neurons and the output values. As said, it is a single layer neural network. We have the weights W11, 12 from X1 to Yi. So we have all the input and output neurons and their corresponding weights. As per the algorithm, initialize the weights with random numbers, learning rate alpha, and the type of neighboring topology scheme which can be used, either rectangular or hexagonal grid 1. And then for each input x value, calculate the square of the Euclidean distance for j equal to 1 to m, d of j equal to sigma I equal to 1 to n, sigma j equal to 1 to m, xi minus wij whole square. So the xi value minus the corresponding weight whole square, that's the Euclidean distance. And then from this, the shortest distance, obtain the winning unit where dj is minimum, where the Euclidean distance is minimum, that is assigned as the winning unit. Calculate the new updated weight wij new equal to wij old plus alpha into xi minus wij old, and update the learning rate alpha of t plus 1 equal to 0.5 into alpha of t. Reduce the radius of the topological scheme. If the stopping criterion is still not met, go to step 2, otherwise end of the algorithm. This is about SOM, self-organizing map. Thank you.